Today, I'm going to tell you about how to store and retrieve high-quality memories in ByteRover. First, let's talk about 3 ways you can store your memories. The first way to store valuable memory is very simple. You just let your agent to do the job. As you can see here, I've already had ByteRover installed on my Claude Code, and whenever you're using ByteRover with your coding agent, doesn't matter if it's Claude Code, Cursor, or Copilot, our default rules will be added into your project. In my project and in my cloud.md file, the rules for using ByteRover tools have been added. Let's get back to the first way to store memory. It's very simple. As you can see here, I gave my Claude Code a task of reading the code base and it started reading through the entire project. Then it using ByteRover MCP server tool to store knowledge into the memory store. And as you can see that it gives really detailed memory for my project. So in just a minute, I'll show you how the memories look like in our memory store. It calls our MCP server tool several times because again, this is a very big task. So maybe it needs really high quality memories to actually capture the code base into the memory store. Okay, the task has done now. Let's move on to the memory store. Okay, this is our memory store. And as you can see that there are in total 3 memories. The first memory that our agent has generated is about Python 2D game. And it goes into the core architecture as well as the system architecture of our project. Then for a second memory, it goes into the level and experience system as well as the talent system of the game. Finally, it goes into the spatial optimization and rendering of the game. So, very detailed memories in just one run. The second way to store memories is to store it manually. Sometimes you want to store these memories by yourself. So Claude Code had just finished the task that I gave it. So the game that I'm working on have different characters, but for now these characters do not have names. So I just gave these names for my characters. So as far as I'm concerned, when I run the game, my character now already have names that I have given it. But it seems that Claude Code has just forgotten to store this into memory, so we gotta do it manually. But you only need 4 words to do it, and these 4 words are store this into memory. So it has run our tool and stored this information into ByteRover. So now when I go back to my memory store, I can see that there's been a new memory added and it's about changing the names of the characters, which is what we've just done with Claude Code. Now we're going pro with the third way. I know the default rules that we added into your agent is really powerful, but sometimes you want to make your customized rules so that your agents work better in your project. Now I give you an example of how the custom instruction file would look like. First of all, it is about storing memory, and I specify what the agent needs to store. So for now, I'm working with a game project. So I want to store maybe the bugs that I encountered in my project. And we also specify things that agents should not be storing, like trivial functions or, maybe things like self-explanatory code. And we also gave agents templates to store memory. The memory should have a title, the topic of the memory. And the memory should also give, the context for why this memory is created, the implementation, like how the code works, the location of the memory, the constraints and related modules or related files. Maybe I have a bug about the game keeps crashing. I also want to store it into memory. The reason we want to be super clear about this is that, we want the agents to store only valuable and high quality memories. Let's compare the memories before and after using our custom rules. Okay, the new memory has been generated. Let's compare both of them. Now let's talk about the memory before our custom rules. So first of all, you can see that it gives real detailed information, but some of them are, unnecessary. For example, the code here is not really wanted because, the code is already in our project. Like storing them in ByteRover is not really efficient because agent can already read it in the code. Again, it stores a lot of code, which is not really what we wanted in memory. Now let's see the memory with our custom rule looks like. So as you can see that it is much shorter than the previous memory and it has a structure that we predefined earlier. First of all, it has the title of the memory, the context for why the memories is generated, the implementation, location, constraints. It looks exactly how we defined it here. So, which is really good because we want structure for our memories. We're done with the storage. Let's move on to the retrieval. Again, we still have three ways for retrieving our memories. First, let your agent do it automatically. As you can see here, I just gave Claude Code a new task, and it already tried to call ByteRover MCP server to retrieve memories. And the task is about, let me show you. Okay, previously we have changed the names of the characters, but I also want the names to appear in the game as well. So, I want my custom name to appear here. So that is the task that I gave Claude Code. And because it is a new section, Claude Code doesn't have any memory before, so it needs to retrieve the memories about our, custom names. So as you can see here, it retrieved the exact memory that we had here, which is our memory with the custom rule file. Okay, I think I'll just let it finish the job, and we'll move on to the second way to retrieve your memory. Okay, the task is done. So I think now when I run the game again, okay, the name has already been added in my menu. How about doing it manually? Let's retrieve another memory, which is a simple prompt. So the next thing that I want to do in this project is maybe create another character. So for now, we have 3 characters, but I think I will make another one. So to get a context for this task, I'm going to tell Claude Code to retrieve the architecture system and the character system of this project. Okay, this is my request. I asked Claude Code to retrieve the character system, talent system, and architecture system of this project. Okay, Claude Code has already run our tool, and it run not only one tool, but 3 tools at the same time. Okay, the task has been completed. If you want truly customized rules for your agent to use ByteRover better, you have to make your own instruction file. You want to make sure that the query completely matches the memories that we have stored before. So as you know that the memory with our custom rules have a title. So we want to format our queries to look, just like the titles of our memories. We also have some rules for how we should be retrieving memory. For high-level tasks, we want very generalized query just like this. But for more detail, for more specific tasks, we want the agent to give a really specific query. We're again searching for the character system, talent system, and architecture system of this project. Let's see how it's different from the first time. Previously, it only run the tool 3 times here, but for now, it goes even deeper into our request. First of all, it goes into the character system, the talent system, just like before, but it goes another step further. It searches for the hero abilities and the skill system, because again, we want to implement a new character for the game. So the hero abilities and the skill system are also really important. And because we're implementing a new character, so it got to look for the sprite rendering mechanism in this project as well. We also need to look for how this character would interact with the existing components of the game. So, very detailed retrievals with our custom instruction file. This is the end of our product guide. Thanks for watching this video. Please try it out ByteRover and let us know your experience.